Alright everyone, here's a second optimization problem, very related but slightly different. Instead of knowing what the constant perimeter is, we're going to know what the area is of a rectangle on the other hand, and with side lengths L by W. And we now want to show that a square is the quadrilateral, is the rectangle specifically that has the least perimeter. So we're going to get a minimum this time. So again, how do we do this? Find the perimeter of a rectangle, two pairs of long sides, two pairs of short sides, add them all up together. You'll get P equals 2L plus 2W and 2 times L plus W. And if you want the area, that's just these two side lengths multiplied by each other. But now we know what the area is, so now we want to solve one of these constraints in terms of the area. So let's go and do, what do I do here? W. This becomes W equals A over L. I'm going to put that into this equation right now for the perimeter. So perimeter as a function of L becomes 2L plus 2A over L. And now, you might hate this, you might not like it, put everything, whether it be radicals or fractions, denominators, into exponent notation. So this is going to become 2L plus 2A L to the minus 1. That way you can easily tell how to use the power rule. And now we differentiate as usual. dP dL equals 2 plus minus 2 8L minus 2. Right? And we want to set that equal to 0 so we can find our critical point, which we don't know at this point whether it's a maximum or a minimum. So this equals 0. And now from this, I can multiply L squared on both sides. So I will get, let's do this first. Let's add this term onto both sides. So we get 2A L minus 2 equals 2. Divide the 2's. I get A over L squared. That equals 1. Multiply L squared both sides. I almost put a 0 there instead of 1. A equals L squared. Square root both sides. And here, typically when you take a square root, you have to take plus or minus. But here, we don't really have to care about that because area is always a positive metric by definition. So this is good enough. Now we plug that back into W. So W equals W is what we're replacing, or L is what we're replacing rather. So W equals A over square root of A, which is the same thing as A over A to the 1/2. This is where the square root notation comes in, turn it into a rational exponent. And now we just apply law of exponents. If you divide by the same base, then you subtract the exponents. So then this just becomes A to the 1/2, or square root of A. And once again, we've shown that the width does indeed equal the length. So we do have the square. But does it minimize the perimeter? We have to show that using the second derivative. So we have dP dL over here. Let's find d squared p dL squared. That will equal derivative of a constant is 0. Derivative of this becomes minus 2 times minus 2 times a constant A. L subtract by 1 in the exponent, L to the minus 3. So this just becomes 4A over L cubed. Now we know that our side dimensions L and W have to be positive. So if L is positive, this necessarily must be positive as well. Let me write this here. L is positive, and so is d squared, do squared, the second derivative. Because the only way this can become negative is we put in a negative length in there, but that's not allowed. So we're safe. So indeed, it minimizes the perimeter. And yay, you're done. That's it. So yeah, please feel free to let me know if this is useful, like and subscribe, and tell me what other comments you'd like on how I can improve the quality of the videos. So then, see you!